Hello folks, let's come to the part 2 video of this exercise 5.8. We are doing the Rolls and mean value theorem, but I think by and large in this part we are doing more of mean value theorem. Only one problem of Rolls theorem we will be doing. So that's how it is. So let's get across with the third problem. The question says that the function f is defined from closed interval minus 5 to r and it is differentiable. And f dash x is not 0 in whatever domain that is prescribed. F dash x is never 0. If that is the case, you should show that f of minus 5 is not equal to f of 5. It is because of this condition that this is not becoming 0. You know that all the three conditions have to be applicable if this has to be 0. But it is not becoming 0 means one condition is not applicable, and the condition which is not applicable is this. That is what they want to say. Okay, now evidently it is very difficult to do this problem. So we do it by method of indirect proof. So what are we going to do? Okay, so what we will do is, let if possible, that's our indirect proof. Let if possible, f of minus 5 be equal to 5. Right. So here what happens? Here, first, f is continuous. Every differentiable function will be definitely continuous. Okay, so that's a class that continuity does not ensure differentiability, but differentiability 100%. That function has to be continuous. Unless it is continuous, it will never be differentiable. So because I have given differentiability, it is always continuous on minus 5 given. Next, f is differentiable. That is also given on minus 5. Third condition, f of minus 5 equal to f of 5. How? By assumption. Okay. So therefore, Rolle's theorem is applicable. Therefore there exists C belonging to this minus 5 such that f dash at C equal to 0. But this is not possible from the given. Right, they have said that f dash x can never be 0. It's being given. That's not possible. This is not possible from the given. This contradiction, with the given and this contradiction arises because our assumption is wrong. Our assumption is wrong. Therefore, f of minus 5 is never equal to 5 is true. Okay, because we chose to show that not equal is not true and equal is true, we came across a contradiction. Now, because we have come across a contradiction, we revert back and we say that is both are equal. That's all. Then we have this next question where they give us a function as we did Rolle's. So also we have to show that this mean value theorem is applicable and we have to check that. So we can start right away. The very first condition, I don't know, why can't we start from above that? Looks more organized. So f of x is x squared minus 4x minus 3 on closed interval 1, 4. We only require that much. Okay. So, here f of x is a polynomial function. Therefore, it is continuous on 1, 4. Right? Every polynomial function will be continuous. Also, f dash x is 2x minus 4. X squared derivative is 2x and minus 4 derivative of x is minus 4. 3 doesn't have a derivative. Is also a polynomial function. And therefore, f is differentiable on 1, 4. Right? Because polynomial function means you take any point between 1 and 4. If you substitute here, you are going to get a finite answer. So that is why it is differentiable. So that's only two conditions for Lagrange's mean value theorem. Then we can check the f dash c value. So and we'll just check do those prerequisites and keep f of a, which means f of 1 is how much? 1 squared minus 4 into 1 minus 3. So how much is that? 1 minus, that is 1 minus 4 minus 3. So 1 minus 4, or rather minus 7, that's 6. Minus 6. I hope I'm correct. Minus 6, yes. And f of 4. 4 squared minus 4 into 4 minus 3. 16 minus 16 is just minus 3. Therefore, by mean value theorem, there exists C such that f dash c equal to f of b minus f of a by b minus a. Let's get those values. F dash c is going to be 2c minus 4. F of b is minus 3. F of a is minus 6 by 4 minus 1. So that is minus 3 plus 6 by 3. So that is 3 by 3, which is 1. So 2c minus 4 equal to 1. Yeah, we are getting 2c minus 4 equal to 1, which will be 2c equal to 1 plus 4, which is 5. So c will be 5 by 2, which is 2.5. Just check whether it is in the interval or not. It is. So that's our logic, that yeah, that's the way we check that whether this point is lying in the interval or not. Therefore, c belongs to, where is that, 1 comma 4, and therefore mean value theorem is verified. Okay, so that's how, like how we did even the roles earlier, that we find the c and we'll check whether c is there in the interval, and that's how we check it. So that's it. Now we can go to the fifth problem. In the fifth problem, they give us same thing, verification of mean value theorem. X cubed minus 5x squared minus 3x in the closed interval 1, 3. Let's check how it is. Same verification of mean value theorem. So first clause here, first clause is f of x is a continuous function, is a polynomial function, right? Therefore, it's continuous on 1, 3. Then also, the second case, when we try to get the derivative of each term, right? X cubed, we all know, is 3x squared. 5 can be outside. This is 2x. So, minus 10x minus 3. Right? Is also a polynomial function. Therefore, differentiable on 1, 3. Okay, so we'll do those prerequisites and keep and let's get f of 1. What is it? 1 cubed minus 5 into 1 squared minus 3 into 1. So that is 1 minus 5 minus 3 minus 8 plus 1 minus 7, and f of 3 is 3 cubed minus 5 into 3 squared minus 3 into 3. You can take a 3 common and do, otherwise directly also you can do 27. 3 3s are 9, 5s are 45. 3 3s are 9. Minus 45 minus 9 is minus 54. Minus 54 plus 27 is minus 27. Okay, so let's put it across. We can see that by mean value theorem, there exists C such that f dash c is f of b minus f of a by b minus a, and f dash c. We have to put c in this. 3c squared minus 10c minus 3 equal to f of b value we have. How much is that? Minus 27. F of a value we have. It's minus 7. Then this is now what? It is 3 minus 1. So minus 27 plus 7 by 2. 3c squared minus 10c minus 3. So this is 6c squared minus 20c minus 6, and this is minus 20. You can have a 2 common from everywhere. So this will become 3c squared minus 10c minus 3 equal to minus 10. A common 2 from both sides and cancel. Then bring the 10 here. 3c squared minus 10c minus 3 plus 10 equal to 0, which is 3c squared minus 10c plus 7 equal to 0. 7 into 3, 21. Right away you can get 3c squared minus 3c minus 7c. We are splitting the middle term. 10 as 3 and 7. So 3c common, c minus 1. 7 minus 7 common, c minus 1. Your factors c minus 1, 3c minus 7 equal to 0. Either of them can be 0. So c minus 1 is 0 and 3c minus 7 is 0. C is 1 and c is 7 by 3. What is 7 by 3? It is 2 point. 3 2s are 6. So 1, 2.3. C equal to 1 we cannot take because C is belonging to the open interval 1, 3 where 1 is not included. So we cannot take C as 1. So we can consider this definitely because 2.3 means it's lying between 1 and 3. Therefore, C equal to 7 by 3 belongs to 1 comma 3. Therefore, mean value theorem is verified. We could do one thing because we are verifying it here. It is a little absurd. So to say by mean value theorem, we can just say consider. Consider. Even here, we will not take mean value theorem and all that because we are just verifying it later. So we'll just say consider. And that's how we verify it. So that's all about it. With the last problem, we meet in the next video. Thank you.